I was not able to uh, get the connection right. Now the connection says it's an excellent condition. Let's continue from where we left. So we had this question where n is somewhere less than 99. It's a positive integer, and n is divisible by square of 4. Square of y, we check that n is divisible by square of y, and we get two different sums. So that we have to check the sum. So 6 plus 4 is 10, and 6 plus 1 is 7. So this is not sufficient. The second of condition doesn't give anything about n. It is just giving some information about y square, y power 4. So it is anyways not sufficient. Now since we are combining, we okay, rewrite this. Right. So since we are combining it, we can actually take one approach where we want some value from here so that we can determine the y, and once we determine the y we can determine the n, and we can take the sum of the digits of n. So let's see, so y power 4 could be anything. Now it's not given that y power 4 is an integer, so y power 4 could be any two digit positive integer. So it could be 11 or it could be 98, right? It is two digit and it is positive. So in that case I am going to take the integer as, suppose, for my ease I will take it as 16, and so since y power 4 is 16 and it is like 2 into 2 into 2 into 2, this is like the easiest one that we can pick, which is an integer also. So in that case 16 is y square, y power 4, and y square becomes uh, 2 into 2, that is 4. So this is 4, and we divide which is n divided by 4 uh, should be having no remainder. So we can write n can be equal to 4 and 8 and 12 and 16. So these all are divisible by 4. In that case, just to be clear, yeah. So in that case, sum of the digits of n here is 4, sum of digits is 8, sum of digits is 3, and sum of digits is 7. Sum of digits of positive integer and when n is less than 99 is not a unique value, so I say this is also not sufficient. So basically, this is also not sufficient, and that is also not sufficient, and even the combination is also not sufficient. So we say that the answer is E. Let's see what is the actual answer though. It seems that 1 and 2 combined are enough to solve the question. Okay, it says that it is C. Very straightforward. Y could be only equal to 3 or minus 3. So n will be divisible by 9. And okay, the answer is E, but why does it say that it seems? Okay, it seems that one work. Okay, it seems like that, yeah, of course. So all these are, so yeah, if we take only integers, it could be only this. But it is wrong. Imagine y is equal to root 3, root 5, root 7, or 3. So y power 4 is equal to 9. And yeah, or 25 or 49. Y squared could be 3 or 4, or 3 or 5 or 7 or 9. Yeah. Did the why they are taking odd numbers? Is it given in here? It's odd. Divisible by square, positive, two digit, odd integer. Oh, yes, I missed this. Right. So even though I solved it for E, but actually if it has to be odd integer, I cannot take this example. In that case, I would have taken root 3 only. So root 3 only into root 3 into root 3 into root 3. That would be the best example. And then this becomes 3. And anything that is divisible by 3, which is 3, 9, 18, or 27 in that case, right? So they still have 9 and this still have also 9. This is 9 though this is 3 in any case. So these two are wrong, different. 6 is also different. So that could be again not sufficient. Okay, let's see now question number 24. Question number 24. Question number 24 says Jana bought only 0.15 stamps, dollars of stamps and 0.29 stamps. So there are two types of stamps. There is 1.5 types of stamp and 0.29 dollar types of stamp. And how many 0.5 types of stamps did she buy? So this is how many of them are there, right? So let's take the x and take the y. So how many? What is the value of x basically? First of all, she bought an equal number of. So first condition is x is equal to y, and yeah, how many 0.5 did she buy? There is no. So Joanna bought this many, this many. So there is nothing we are missing, right? Joanna bought equal number of times. So if there is equal number, x is equal to y, but we don't know what is x, we don't know what is y. This is not sufficient. Second thing is, it says she bought $4.4 of $4.40 worth of stamp. So if this is a condition, then it has to be 0.15 into x plus 0.29 into y, and there has to be only one value that actually satisfies this condition. Mm, there are two variables I would say, and there is one equation. You should not be actually solvable, but if we have only one, uh, if we can prove there are more than one values, we can say it's not sufficient. Let's find at least one value. So in that case, what we will do is uh, we again we know that we have to get uh, first of all I'll take all the zeros to make it easier. So 29y and this is also divided by 10. 100 this is also divided by 100 and 4.40 is also divided by 100. So I'll cancel the hundreds, which is 440 15x into 29. So basically we have to get 440 from the combination of 15 and 29, and we know that 15 is 15 30, right? 45 60 75, like that it will continue, and it will only have 0 and 5 in its uh, units position. Now same as what happens with 9 is, yeah, so it and then 9 goes it like 9 on the 9 18 27, and yeah, so it can have different uh, units digits. So basically it will have all of them. So it has 5 4 3 2 1, right? Uh, but 9, yeah, and 0 as well. So there are only two conditions where 9 could actually meet, is when it is like 5 is the vision. So 29 into 1, this is into 2 into 3 into 4, and when it is into 5, so 1 is that 29 into 5, right, which becomes 45, and 5 to the 10, and 10 plus 4 is 145. This is one condition. And when it is into 10, that it is 290. Then it is 290, then we subtract it at 440, we get uh, 0, and here it is 14, which will make us 150. So that means if we have 10 of these and 10 of these, basically x is equal to 10, y is equal to 10, we get this answer as 440. This will be 1.5, 1.9, 4.40. Now, is there any other solution? Let's see What happens when it is 145? When this is 145, we have to get something like 395 here. Sorry, 295 here. So for getting 295, the 295 should be divisible by 15, and if we divide 295 by 15, we will see that it is not divisible by 15. See, 15 ones are 15, and we see here it is 145. So 145 is right. So we again know that 15 tens are 150, and this will have not come as tens are will be nines are. So it is 135 and not 145. So in that case, this is not divisible 1 and 15. So this is not the value. Another value we can think about is when 29 is multiplied by 15 instead of, because next round of 5 will come there. So in that case, uh, we know this is like 290 plus 145 will give us 5, and this will give us 3, this will give us 4, 435. That means we are left with only 5 values for 440, so that is not possible. So basically only one value, that which is 10, that is satisfying it, so we have to go for a B answer. Any number of stamps could be purchased for 5, 5, 10, 10, 100, 100 insufficient. The total value of 0.5 stamps must be a dollar amount and ends with 5 or 0. That's right. And in order to for total value of both the stamps to be equal to 4.40, therefore the total value of 0.29 stamps must be equal to the dollar amount which ends with 5 or 0, which is the same thing that we did. That would only occur if the multiple of 5, yeah, if a multiple of 5 to 0.29 stamps are purchased. 5 to 9 stamps would be 145 and 295 to make 440, but 2.95 is not a multiple of 0.15, so not good. And here they are taking 10 stamps, which is can be purchased, and here we are taking 15 stamps, which is again not good. So this is the same thing that they did, that we did, and answer is B. Fine. So in our series of 25 questions, I think this is the last question. And let's see how interesting it is. So let's see the 25th question. It says that if x is a non-negative integer, so whenever it is a non-negative, that means x is equal to 0 or x is greater than 0. There are two conditions, and is an integer. So it is an integer. That is one more thing that is given. Then x factorial plus x plus 1 is a prime number. So if is this a prime number is the question. So for having for being a prime number, it should be only divisible by itself and 1. So basically it should not have any factors other than itself. So let's see, if x is less than 10, what happens? So I take one value where x is less than 10, and it should be, x can be equal to 0, it is not negative, so x is 0, 0 factorial is 1, and plus x is 0 and this becomes 1, which becomes 2. So for t 0, this is prime, and let's take another value. Suppose I take 3, 3 factorial plus 4, 4, and here 3 factorial, this I think should always be prime, but let's see. Yeah, 3 factorial is 6, and this is 4, which makes it 10, which is not prime, right? Uh, yeah, 3 to the 6 plus 4 is 10. This is not prime. So definitely if it is less than 10, we cannot say that it is prime. Um, so we say this is not sufficient. Let's take number 2 where x is even. So x is even means x can be anything 2 or 100. So let me take, since we have a factorial here. I cannot take 100. I don't know the factorial of 100. But let me take 5, yeah, let me take 4 or something like that. So let's take 2 in that case first. I'm not taking 2 here. 2 factorial is actually 2 plus 3, which becomes 5, which is prime. Let's now take some other value like uh, um like 4. Let's see. So 4 factorial will be 24 plus 4 plus 1 would be 5, which is 29, which is again prime. Let's take something else mm, like 6, the next even. I'm taking the least values because we have to calculate the um, we need to calculate the factorial. So basically this will be 7 and 5 is 120 and 6. So 12, 6 is 72 and 720 plus 7 is 727, which is prime. Uh, so okay, for 6 also it is happening like that. Let's take 10. I can take 10. So 10. So 6 factorial is 720. 9 into 8 is 72. And then we have a 10. Plus I have an 11. So we need to know that what is the calculation of this. So if somebody knows the 72 square is awesome. I don't know it, so I need to just calculate it. So 72 into 72. So first I'll make it into 2, which will become 144, and then this will become 154. So, sorry, something is wrong. 7 to the 14, and 7 to the 49, which becomes 504. So it becomes 4 and 8 and 1 and 5. This guy is being added by 11, which will make it 5 and 9, 1, 5. So this will definitely be divisible by 5 because it has unit digit 5. So definitely what I understand is this is not a prime number. But this is when I've taken 10. What happens when I take, so at least till this point it is uh, when it is 10 it is not prime. Let me take the value when it is 8, because for all the others when we combine we just need to check 8. For all the others we have checked. So when it is 8, so what was our calculation? Yeah, so yes, 720 is 6 factorial plus, okay, we didn't multiply 7 here, no, here we did. Plus, 7, yeah, we have to multiply 8 and then you have to add 9 to it, right? So 8 to the 16 and 8 7 the 54 and 155 and 556 plus, oops, something's wrong. Yes, this has to be this value. So 0 I didn't take. Yeah, and 9, that becomes 55969, which is again a prime number. So if we combine we get that all every time it is a prime number. So I think it is sufficient. We have to answer B. Let's see. The best approach to this is will be test numbers. Note that since the question is yes or no, all you need to do is prove their insufficiency. First one is insufficient. We proved it by taking 0, 2 and 3. We took 0 and 3 and we made it as insufficient. Let's take the second one where it says this is also insufficient. Why? Because it took 0 and 2. One is prime and another is not prime. What we did for the second one is we x is even. So 0 is considered to be even in GMAT. Yeah. So if we take 0 and 2, both are prime. Now consider they are considered 8 also. Yeah. So 8 is 9. This expression must be divisible by 3. Okay, so we don't need to do solve everything. This is easier way. So if we have this is divisible by 3 because we can take count 3. Therefore, it is not a prime. This is more of a intelligent way instead of killing ourselves with the calculations. So definitely this is not sufficient. Since we have found a case where the prime and one case where not prime statement true is not sufficient. 1 and 2 insufficient. Why? Since the number 2 gives prime and number 8 gives not prime. 8 gives not prime, right? This guy is actually, let's see, this is 10. Uh, this is 15. So 10 plus 15 is 25. But it is not divisible. Or maybe my calculations are wrong. Should be divisible by 3. Let's see. 720 into 8, 8 0 0, 8 16, 8 7 is 54. This becomes 55. Mm, I don't know. Let's see what is the value of 8 factorial. 8 factorial. Okay. What happened? My internet died or something. Okay. Oops. My calculator. Yeah, I have a calendar instead of calculator. Yeah, so 8 into 7 into 6 into 5 into 4 into 3 into 2 into